Right, 5.1 angles of triangles. The central question is, how are the angle measures of a triangle related? We're going to look at, kind of review some classifying triangles by sides and angles. We're also going to find the interior and exterior angle measures. Okay, we're going to define what we mean by an interior and exterior angle. And here we go. This should be review from previous classes. Classifying triangles by sides and angles. Call that a triangle is a polygon with 3 sides, and these are the different types of ways that we can classify the triangle. We've got scalene, isosceles, equilateral, acute, right, obtuse, and equiangular. I do want to point out that an equilateral triangle is also equiangular. These two are the same as far as the same type. If the sides are the same, that means the angles are the same. And this brings us to our first example, classifying triangles by sides and angles. We want to look at this triangular shape here in the middle, and we want to classify it based on its sides and also by the angles. Now, looking at the description and looking at these little tick marks right here, we know that it is an isosceles triangle, because 2 of the sides are equal. All right. Now it says to measure the angles, so I'm going to use my protractor. All right. Notice that this tip right here, that little hole, has to match up with the vertex of this triangle. And this little red line right here, if you can see it, has to line up perfectly on this little black line right there. And when I do that, I use my protractor and I measure across. This is going to be a 55-degree angle here. And if I do that going the other way, coming up this way, this is also 55 degrees. Alright, so I got 55 and 55. We need to measure this other angle. And following that, looks like that's going to be 70. So we got an isosceles. We'd call this an acute isosceles, if I can spell. Excuse me, ACUTE, acute isosceles triangle. All right, example number 2 says we want to classify the triangle OPQ by its size and determine whether it's a right triangle. So we got 2 things we got to do with this. Here's another way that we're going to ask you to classify these. We won't give you the links, we'll put them on a coordinate plane. So if I want to classify by its sides, I need to know what these links are. So what I'm going to end up doing is I'm going to have to put these in to the distance formula. So the distance from O to P, I'm going to put that in the square root. So it's going to give me -1 minus 0 squared plus 2 minus 0 squared. And that comes out to be the square root of 5 if I simplify that. And if I do O to Q, I'll put that in the square root. I'm looking at the coordinates. It's going to be 6 minus 0 squared plus 3 minus 0 squared, which ends up being square root of 45. And if I do P to Q, the distance from P to Q, it's going to be 6 minus a -1 squared plus 3 minus 2 squared. And if I simplify that out, that comes out to be the square root of 50. Alright, so all these 3 are going to have different lengths, so that means it's going to be a scalene triangle. Right. And now I got to determine whether it's a right triangle. All right. The way to do that, there's a couple different ways. But what we're going to do is we're going to go back to something we've done in the past. We're going to look at slope. So I want to find the slope of OP. And remember that that's right as over run. So it's going to be 2 minus 0 over negative 1 minus 0, which comes out to be negative 2. Now I want to do the slope of OQ, which comes out to be 3 minus 0 over 6 minus 0. That's 1/2. Okay, and then I notice here that these are opposite reciprocals. I can put negative 2 over 1, and then I have 1/2. Remember that if you flip the fraction and the signs change, this one's negative, this is positive. They are opposite reciprocals. Also, you can remember that the product of these two, if you were to multiply these, you would get a negative 1. So I know that segment OP is perpendicular to segment OQ, which would mean that this is going to be a right scalene triangle. All right, next we're going to talk about what's called interior and exterior angles. If we kind of extend out the lines in a triangle, we get these extra angles right here. These ones that are inside the polygon, inside the triangle, these are referred to as interior angles. Those three there. And then exterior angles are these outside angles that are formed right outside the triangle adjacent to these interior angles. All right, which brings us to these next two theorems. The first one you should be familiar with. This just says that the angles inside a triangle, if we add them up, angle A, angle B, and angle C, we're always going to get 180 degrees. It doesn't matter what the triangle looks like. All the angles inside a triangle always add up to 180 degrees. The one that might be new to you is what's called an exterior angle theorem. And what that says is that this angle 1 right here, this exterior angle 1, is equal to the sum of angle A and angle B, to these two angles right here. Okay, so these two angles add up to this one exterior angle. All right, so let's kind of put that theorem into practice. If you notice, I got this angle JKM, this exterior angle here. Okay, and I want to solve for x so that I can find out the measure of the angle JKM. And so what I know, based on the theorem above, is that the angle x plus 70, these two angles, the sum of them has to equal this exterior angle here, 2x minus 5. Okay, so if I'm moving things around, I'm going to move this x towards the right. This is 70 is equal to x minus 5. Add 5 to both sides. X is equal to 75. Remember not to stop because we're looking for the angle. So I want to do 2 times 75 minus 5. And that comes out to be 145 degrees. So the measure of angle JKM is equal to 145 degrees. Next we have what's called a corollary, and that's just kind of an extra segment, an extra idea to a theorem. So if I know that all three angles inside of a triangle add up to 180, and I happen to have a right triangle, which means one of the angles is 90, then the other two, angle A and angle B, have to add up to 90 because 90 plus 90 would give me the 180. Alright, so for this, using this corollary, the measure of one acute angle of a right triangle is 1.5 times the measure of the other acute angle. Find the measure of each angle. Alright, a good strategy for geometry is to go ahead and draw this out. So I know it's an acute angle. I know it's a right triangle. Excuse me. So I know one of the angles is 90. Right. one angle is 1.5 times the measure of the other angle. So if I let this angle be x, the other one is 1.5x because it's 1.5 times bigger. So I would set this up as x plus 1.5x equals 90 using the corollary. So this would be, remember that there's 1 here, so this is 2.5x equals 90. And then I divide by 2.5. And that tells me that x is 36. And then for the other angle, we can do it one of two ways. We can either take 1.5 times 36, since this one is 1.5 times bigger, or we could also just do 90 minus 36 and say these two angles here are complementary. And either way, we get 54 degrees. Alright, so those are my two angles, 36 degrees and 54 degrees.